Can data science predict the winner of the 2026 World Cup? Well, we'll find out. So the past couple of videos I've done have been on very heavy topics. So I wanted to pivot this video to something different. And with the 2026 World Cup coming up on June 11th here in the United States, I figured that this would be a fun one to do. So first off, I am not a soccer expert, right? The video pitch in my head for this was, can someone who knows very little about soccer predict who will win the World Cup using data science? And for people that really follow soccer, this should be interesting to see because I'm unbiased in this, right? I can make a complete fool of myself or look like a genius. And I'm from the United States, so I would like to see them win, but that's just my personal opinion and not what this data or not what this video is about, right? We're going to use data science. But I should clarify that I do track sports and post videos on them, specifically the big four here in the United States: baseball, basketball, hockey, football. And I probably will use models and techniques used to analyze those sports here. And my other channel is related to sports cards and sports card openings. So I'm not oblivious to sports. It's just my soccer game knowledge is very limited. And I know key players like Lamine Yamal, Messi, Ronaldo, just from the card world, right? I track and know big players in certain sports, but yeah, and I have cards on them, but that's about the extent of my knowledge. And with that, welcome everyone. This is Data Divided, where I break data into what matters. So you know I'm not a soccer analyst, you know I like sports cards, and I have a YouTube channel. But beyond that, I just want to quickly run through my background as it helps give context to how I think about things, analytics, etc. I have 13 plus years analyst experience, mostly in the wealth management space. Education-wise, the thing that is most relative to what we're doing here is I have a master's of science in data science. So I have a background in analytics and data science. No sports analytics background. Hopefully some of those other principles that I've learned in finance and things like that can help this video or this analysis, all right? Also, if you'd like to support the channel, I have a couple different things here. Obviously, like, subscribe. I put a link to my eBay store, so if you are in the market for any sports cards, go check that out. And then I have what's called Buy Me Coffee. It's kind of like an online tip thing. If you got something useful out of this and like to leave a tip, that would be great. Much appreciated. Thank you. So I mentioned I have a master's in data science, and that's kind of the framework I will be following through this. So I want to quickly touch on what data science is. If you were to ask this question to multiple data scientists, you probably get different answers. But how I like to think about it is just kind of the 6-step scientific process. First, identify the problem. In this case, can non-soccer guy predict who's going to win the World Cup, right? Then gather the data. I have all kinds of different data sets I've gathered for this analysis, and I'll walk through all that. Have to cleanse the data. You're just taking all this data, you got to structure it. Maybe you're not going to include all the columns in your analysis from the data you pulled. Is there missing data? All that. You kind of have to take care of all that in the cleansing process. Then you have the model selection. So I have a couple different models I'm going to do, and I'll walk through that here later on, but there's some fun stuff there. And then evaluate results and present. So with this, obviously, you're going to see I'll walk through like steps 2 through 4, and then I'll present, we'll evaluate results, and then obviously I'm presenting them, okay? But you're not going to watch me gather data or cleanse data or things like that. But all right. There's a couple foundation things we got to talk about first, so it's just not me putting a bunch of outputs and saying, trust me, okay? So I wanted to give you this analytical framework. Here are the 3 analysis that I'm doing, and they're independent methods of each other to see or predict who will win. Now, these are very similar to what I would do for other sports like basketball, football, hockey, baseball, etc. So I just took that same kind of methodology and applied it here. You can use these for all sports. They're not soccer specific, but we'll walk through. So the first method is the Monte Carlo simulation. Basically, I simulated the tournament thousands and thousands of times. And I'll show you a little bit of how I did that and other things, but just this is what I did, okay? Every match outcome gets probabilistically modeled, and over enough simulations, patterns start to emerge. Think of it like running alternative World Cup timelines over and over again, right? The multiverse. But so one tournament might have Brazil winning, another might have France, another might have Spain, etc. And after enough simulations, you start to see which teams consistently survive the chaos, almost like a dating show, right? Where like there's a winner at the end, and you're simulating a dating show a million times and see, is there somebody that keeps getting the final rose, as an example. The reason I use this approach is because with soccer, it's incredibly random, right? A single red card, penalty, or unlucky bounce can completely change the tournament, okay? So instead of like pretending I can predict exact match outcomes, the simulation lets probabilities naturally emerge. The second is the historical champion similarity analysis. And so this second method it's a different look, right? What do World Cup champions actually look like statistically? Do they score a lot? Do they defend well? Do they dominate possession? Did they just have peak at the right time and have a good run in the playoffs, for other sports? But so this analysis compares current teams against historical championship profiles. Basically, which modern teams statistically resemble past winners the most. And this is one of the coolest parts of the project because you start seeing patterns repeat across generations of football. Different eras, different players, different coaches, but certain traits keep showing up, right? The third is the expert consensus analysis. I know people use this a lot in the NFL, where you have all these different NFL analysts ranking players, things like that. So very similar. It's a layer where I aggregated all the different analyst consensus rankings of who's going to win, right? Because those analysts have a better understanding of the game than I do as somebody who's new to this, right? And they can do their predictions based on chemistry, tactical systems, depth, tournament experience. So this aggregates their predictions, basically acting, what does the football world collectively think? And that's where what's interesting is where the analysts agree with the models and when they completely disagree, right? So like, what if I predict these things and then the analysts have a completely different viewpoint on it, right? So why multiple methods? Because it's important to me. I didn't want one model making all the decisions. If all three models independently start pointing toward the same teams, and that's where things start getting really interesting, right? You're verifying what you're doing. You're not putting all your eggs in one basket. And that's kind of the entire point of this project, right? Not to guarantee the winner, but to see if meaningful patterns emerge when you attack the World Cup from multiple analytical angles. So let's quickly talk about the data that I gathered. I'm going to go through this real quick. I know this isn't the most entertaining aspect, but I want to cover my bases here. So this is for the Monte Carlo simulation. I have a couple different data sets that I put together. I have historical match results, right? Because the core of this entire simulation starts with historical international match data, basically decades and decades of real match outcomes. Who won, who lost, who scored, etc. And this matters because simulations are only as good as the historical patterns feeding them, all right? Then I have penalty and shootout data. I also wanted to include this because, let's be honest, the World Cup loves penalties, and you can dominate a match for 120 minutes and suddenly your entire tournament comes down to 5 kicks, right? So I wanted to add that layer as well. One of the things is opponent adjusted ranking. So I use this a lot when I do basketball analytics. It's just basically adjusting for the strength of the opponent. A 4-0 win over a really bad team is different than a 4-0 win over a really good team, right? So you want to adjust for those essentially. Then historical strength runs, that's basically rankings, team rankings. And then you have, obviously you need this current World Cup groups and structures. What is the tournament brackets, right? So you need that aspect for simulation. And then once all this gets combined together, that's when the fun begins. Now the simulation goes out, and I'll obviously show you how I did that in the results. Okay, so this is the data I pulled together for the second analysis, the historical champion similarity analysis. So first, I built a historical reference set of actual World Cup champions. Basically, what did winning teams historically have in common? Were they dominant offensively, elite defensively, balanced, efficient, etc.? Then I did some team performance metrics. So it gets a little nerdy here, but I engineered performance metrics for every historical World Cup team, like goal differential, statistical efficiency. Same thing you would do with all other sports, right? You just you're plugging in specific numbers for this. But yeah, so I did that. And then I did current teams master. So that's the reference table I'm joining to. Who are on the current team for the World Cup, right? For the World Cup teams, excuse me. And then I did what's called the similarity score. And that's a PCA, that's a clustering analysis, and that's the output for that. And that sounds complicated, but it's really simple. Imagine plotting every team into a giant football or soccer universe based on how they perform statistically. Teams with similar characteristics naturally start clustering together. So if a current team starts landing near historical champions, that gets very interesting. Think about like your first day of school and you walk in and like everybody's just a mass of people, and then in college, whatever, and you look and like, oh, that guy, he's got a Twins jersey. I'm gonna go talk to him. I'm a Twins fan. Or that guy's got a Anaheim Mighty Ducks hockey jersey. I don't know, whatever. I'm gonna go talk to him. Things like that, right? So that's what clustering is. It's like you're just kind of grouping things together. Similarity, okay? And I really like this analysis because it's less about predicting random match outcomes and more about identifying which teams look structurally built to win a World Cup. And I think it's important. And we'll get into everything farther on here. Okay, this is the data for the third analysis. So the expert consensus, right? This is what the soccer world thinks, okay? And so I pulled in analysis consensus. And so I have from like ESPN Football Club, CBS Sports, Fox Sports, Sports Illustrated Soccer, the analysis, and then I got consensus percentages from the same sites, and then build out an analysis table and text. So this is all basically from the analysts, on ESPN, CBS Sports, Fox Sports, Sports Illustrated, etc. Right? So pretty mainstream sort of sources. Didn't go anything crazy for super soccer specific, I guess. Analysts, okay? Just kept it very broad. All right. So we got engineered features and calculated systems. Basically, at a high level, what this is just getting the process of getting the data ready for analysis. So a great way to show it is the bottom, the transformation pipeline. You have your raw data, which I talked about, all the different data sources. Then it gets cleansed and normalized, and then you do featured engineering and calculations. So think about like if you were to have an Excel spreadsheet and you had, I know I lost everybody once I said that, but you had like you all have a business and you make $100 a month from your business, right? So you have January through December, and you added you wanted to do an average of what you made or the total or anything like that, that would be a calculation or feature engineering, right? You're doing some sort of calculation for them to do analysis with, and it's a high level kind of what that is. Feature engineering is a little different, but so let's walk through this, okay? So the first thing is the opponent adjusted ranking system. I do this for all my sports analytics. It's such an important thing. So think about like with the NFL, and you have the NFC Championship, right? And one of the teams has a perfect record, but they had the easiest schedule in the NFL. The other team had maybe 3 losses, but they had the hardest schedule in the NFL. Well, which team would you take, right? So you would have to, in your ranking system, you would adjust for that one team that had the perfect record played easy opponents, and then you would have to strengthen, right? So it's that adjusted ranking system, okay? That's basically what that is. The next part is, this is more performance, featured engineering. So basically, calculated team metrics for every World Cup team in every year, essentially. Like goals scored, goals allowed, points per match, tournament of progression, scoring efficiency, things like that. I'm creating calculations for them to then add into the analysis. Expert consensus aggregation. I talked about that. Basically, I'm parsing and extracting mentions, extract team rankings and tiers, counting and normalizing. So if Brazil was mentioned this amount of times, that's part of the count, or whatever, things like that, essentially. And then I have my current team's master table, okay? This is the heart of it. It's my core master team data set. I have my opponent adjusted team ratings, right? My expert consensus scores, my normalized team names and identifiers, confederation or the confederation and region, right? World Cup qualification stats. So all of that. So it's like it's the brains of the operation. It's all these different things I've done, then created a master table. So now we're ready for the analysis portion. All right, so we're going to nerd out a bit. I normally don't include this in my presentations. Y'all are going to be my guinea pigs. But think about it as like a peek under the hood. It's like popping the hood of your car to look at the engine. That's basically what this is, okay? So all of my analysis I do in RStudio. And on the left, I have just some fun kind of image of that where it has like number of simulations. But each one of these things on the left are the different functions, right? So you have the simulate group match, okay? Then you have simulate group stage fast, the simulation L12 groups. Then you have simulate knockout match, simulate knockout round fast. All these different functions that are running for the simulation, okay? So then you have, first is the inputs. This is sort of the pipeline of the simulation. The code is doing this on the right, if that makes sense. So we have our input section, okay? So to feed this simulation, the engine needs teams, group structures, host nations, probability systems, and tournament rules. This is basically the feed the beast data phase. And because it's the World Cup, it has 48 teams, okay? And then so this gets way bigger than older tournaments. So yeah, it's a lot of things to simulate. But then you have the simulation engine, okay? And this is where the model starts generating outcomes. Every match gets probabilistic outcomes, right? Not scripted results, probabilities. Meaning stronger teams usually win, but chaos is always possible, so it's random, okay? Next is the group stage logic, all right? This is the iteration loop, okay? 10,000 plus tournament runs, meaning I am running this tournament over 10,000 times, okay? And this is where it's like the important part, because we're not storing full tournament histories every time. Instead, the model uses running counters, meaning Every simulation updates advancement totals, championship counts, and ranking distributions. Okay? So, in theory, it's after simulation 1, here's who the champion was. After simulation 2, etc., etc. And then at the end of it, you're looking to see which team won after all those different simulations. But then you can adjust. I won't go into that, but there's some other things. So, but that's just at a high level of what this is, okay? But there were some different things that were done to look at different simulation types, and I'll walk through that more, but I don't want to lose everybody, okay? So let's go on to the next one. Okay, so let's peek under the hood for analysis 2, the championship, historical championship similarity, all right? So this entire analysis is built around one concept. Championship teams leave statistical fingerprints, okay? So statistical fingerprints are how often they score, how often they concede, how dominant they are, how efficiently they win, etc. All right? So the first step is the historical champions profile. So first I build profiles for every historical World Cup champion. Every champion becomes a vector of performance metrics. Yes, I just said vector in this, but yeah. So we are quantifying championship behavior. Goals per match, goals against, goal differential, points per match, tournament progression, etc. Okay, so building a profile, like a dating profile, something like that, right? Okay, so step 2, engineer current team features. So then I do the same thing for current teams, but it's where it gets kind of tricky. Modern football isn't identical to like 1970s football or soccer, right? Scoring environments change, tournament structures change, styles evolve, essentially. So you have to normalize all that. And this is why feature engineering is so important in data science. The model is only as good as the features you feed it. Garbage features, garbage outputs, right? Good feature engineering is basically teaching the model what actually matters, okay? All right. So next is the comparable feature space. Then I combine historical champions and current teams into one unified feature space. All right. The goal is apples to apples comparison. We want 2026 Spain sitting mathematically next to historical champions, statistically, not emotionally, statistically, right? And then you have the PCA dimensionality reduction. I'm putting these words out here. Stay with me. I don't want to lose you. Okay, and this gets nerdy, but it's the principal component analysis, basically compressing massive multi-dimensional data into simplified structures while preserving the important statistical relationships. Think of it as like reducing noise while keeping the signal. We are shrinking complexity without destroying meaning, okay? So think about it like this. It's kind of like taking 100 of NFL football variables and then compressing them into the core DNA of what makes a team successful, if that makes sense, right? There's certain dimensions, certain things that make certain teams better than others, okay? Then you get into similarity distance modeling. So that's calculating similarity distances, meaning how statistically close is each current team to past champions, okay? And honestly, that's one of the coolest analysis things in this project, because sometimes a team barely people talk about quietly starts matching historical champion profiles, while heavily hyped teams don't actually resemble past winners at all, right? That narrative, okay? All right. Last one we'll peek under the hood of. Analysis 3, the soccer analysis consensus, excuse me. So this analysis basically takes hundreds of predictions from football analysts and media outlets and compares them against the simulation model and historically similarity model that we just covered. Basically, are all the experts seeing the same numbers we are, essentially? Okay? So first is to ingest analyst sources. So first I scraped analysis predictions from all over the football world or soccer world, rankings, tier lists. I listed out the sites. It was like ABC, NBC, Fox Sports, ESPN, things like that. Next was the to clean and normalize the data, which is a little bit of chaos because every outlet formats things differently. Like one might say US, another say United States, another say United States of America, things like that. So you have to normalize all that, okay? So once all the team names are normalized, rankings, percentages, then it's to build the analyst consensus model, okay? And this is not like just counting mentions. Some sources carry more weight than others. Some analysts are more reliable historically. Some outlets produce more detailed predictions. So the model has some weighted scoring to that, all right? And that's actually a pretty interesting aggregation problem because consensus isn't binary, it's probabilistic, right? You're trying to quantify how strongly does the football world, I keep saying football, I should say soccer, I think I'm speaking World Cup, I'm using the world term, but the soccer world collectively believe in a team, okay? Then compare the analyst versus data models. I compare the analysis consensus against both data-driven systems, the simulation model and the historical champion model. Okay, basically checking how do the analysis compare to the algorithm side. All right, and it's like a debate, right? Like you watch ESPN and everybody has the five people on there on the stage who's going to pick who's going to win the Super Bowl, whatever. You have all the different analysts. It's a similar thing where you have, instead of five people, you have the algorithm, the simulation on one side, and then this is the analyst on the other side. So kind of interesting to think about, right? And then it's the triangulation, okay? And this is one of the coolest concepts because you have three completely independent systems: simulation, historical, statistical similarities, and the human or the analyst expert consensus. All pointing to whatever teams. So super fun. All right, let's move on. Okay, so we actually get into the fun stuff here now, the outputs. Okay, so I've covered all the bases. I've explained the data. I explained the analysis that I'm doing, how I ran the code for the analysis, the framework of it, the pipeline. Now we're actually getting to the actual output, okay? And so this is the first analysis. This is the Monte Carlo simulation, right? I'm randomly simulating those 10,000 tournaments across three different probability models. Okay. And one thing that's important here, I didn't just run one simulation. I ran three different versions of the tournament, right? Think of it like testing three different realities, okay? Model one is the equal probability. And this model is basically pure chaos. Every team has equal odds in every match. Brazil, same odds as New Zealand. Spain, same odds as Iran. And when you do that, the probabilities flatten out almost perfectly. Nobody dominates. Every team ends up around 2%, okay? And why did I do that? This is basically the control test. It proves the simulation itself isn't secretly favoring teams, okay? The model only starts creating separation once team strength gets introduced. Model 2, now we get into the opponent ingested. And this starts to get a little bit more realistic. Instead of every team being equal, the match probabilities are adjusted based on team strength. And I've explained how I did that team strength, how that was calculated. But anyways, so stronger teams are more likely to win, but upsets can still happen, right? The important part, notice I said more likely, not guaranteed. And that's the entire point. Football is too random for certainty. One bad match and you are gone, okay? So what happened? As soon as realistic team strength gets introduced, Spain jumps to the top at 22%.
Argentina at 14.7, France at 10.7, England at 6.6, etc. The elite teams start separating themselves from everybody else. And why this happens. Well, basically, the model isn't asking can Spain win one game, it's asking across 10,000 tournaments how often does Spain survive the entire path, right? And that's a much harder question. And the reason why you see that such low percentages where it's not like 50% or higher is because there is so much randomness within it, right? You get a red card or something happens, you get tournament, you get to these shootouts. There's a lot of different paths or things that could happen within a tournament, okay? Almost like NCAA for basketball. Like there's you have your top teams, but it's not the final four isn't it always the top four teams. There's a lot of things that can happen through that journey, right? Um, okay. So let's go to model 3, the favorite heavy, okay? This is where I push the model even harder. The favorite heavy model gives you stronger teams, gives the stronger teams an even bigger advantage. Basically asking, what if the elite teams are really elite? What happens? What changed? Well, Spain jumps all the way to 33%. And that's huge in World Cup terms. But even then, the model is still saying Spain loses most of the time. Huge point. And honestly, this is one of the biggest takeaways from the whole simulations. Only even the best team only wins about 1/3 of the time. And this shows how insane the World Cup really is. Injuries, momentum, penalty shootouts, one bad half, everything matters. Okay? But here's what caught my attention. Spain stayed near the top in both weighted models, and that consistently matters, right? One model can be noise, but when multiple systems keep producing the same result, that starts becoming a signal. Okay. Another interesting finding: the top teams account for most championship outcomes, which honestly kind of matches real soccer history. The World Cup usually gets won by a small group of elite nations, usually, but chaos exists. All right.
All right. Now we have the output for our second analysis. So this is the historical champion similarity results, comparing current teams to 19 historic World Cup champions, right? So the key takeaways from this, and I've already gone over like the ins and outs of this, how this was calculated, all that kind of stuff. But the big takeaways are Spain leads the field with 31.8% title probability and elite all-around performance. Historical champions set a high bar. Current teams are still chasing championship level consistency, right? Defense wins titles, okay? Just like in the NFL. Historical champs allow just 0.6 goals against per match on average, all right? And the top 8 teams account for 73.5% of all championships in the simulation. Okay. So yeah, if you walk through this to the top left, you'll see the top contenders by championship probability. We have Spain, Argentina, France, England. So all those top 8 teams account for 73% of the probability. Okay. Um let's see what other interesting stuff on here. So if we look at it as we noted, the defense wins championships, and 5 the current top 10 performance snapshot, we have the defensive strength score. Spain is in the top, and then you go to Argentina, France. So defense is very heavy. Interesting, Morocco in the top 10 as well. I don't know, maybe not. I see France and England, Germany, like Italy. I don't know. Let's assume some of the other maybe European countries would be in there, but dark horse contenders, teams most similar to past championships that are outside the current top 10. But you have Croatia, Uruguay, Switzerland, Denmark, Austria. Okay. So cool. That was the output. Once again, Spain on top. Okay, so this is interesting for me because what do the experts say? I am not an expert, as I mentioned. I'm just a data scientist here, pulling all this data together, running stuff. So I'm curious to see what the experts have to say. Okay. Okay, so the big questions. So because it's one thing for a simulation model to love a team, it's another thing when analysts, journalists, and football experts also keep putting the same team near the top, and that overlap matters. It's like a validation, right? You know what I mean? So for analysis 3, this is a consensus engine. I scraped and aggregated predictions from multiple football analysts and media sources, then converted all those opinions into structured rankings and scores. And why is this useful? Because analysts see things raw data sometimes misses. Injuries, locker room chemistry, manager changes, young breakout stars. They're up to date on all the information. They're checking X or Twitter. They're having conversation with people behind the scenes. You know what I mean? You're not going to see that stuff just based purely in the data, right? So the left side, this is the expert consensus rankings. Every team gets scored based on a combination of how often they were mentioned and how highly they were ranked. Okay. For example, if every analyst keeps mentioning Spain as a favorite, Spain's mention score skyrockets. That means the football world is repeatedly pointing towards the same team. But I didn't want one loud source dominating the rankings, so I also weighed source diversity. If a team appears across ESPN, Fox, CBS, The Athletic, betting and analytics sites, etc., that's stronger than just one analyst hyping them up, right? Like maybe one person has a large platform, they just amplify it. So you got to look across multiple sources. And Spain's on top. So why Spain scores so high? Okay. And once again, Spain finishes at the top, which is becoming a recurring theme now. The simulation model like Spain, the historical similarity model like Spain, and analysts like Spain. When independent systems start agreeing, that's where everyone should start paying attention, okay? Biggest agreement section. This table here might actually be the most interesting part of this because this shows where experts and data models tell the same story, okay? If a team ranks similar across the simulation, the historical model, and expert opinion, their disagreement score stays very low. And that usually means the signal is strong. It means multiple independent approaches are arriving at similar conclusions, okay? But then you have disagreements, the biggest disagreements, okay? And this is super interesting because this table shows where analysts and data completely disagree. Some teams are loved by analysts, but the numbers really don't support them. You have like Ghana, South Korea, Ivory Coast, Sweden, and other teams barely get talked about, but the data quietly loves them. So it's super interesting. Uh, and this happens in every sport, by the way. Fans and analysts fall in love with narratives, but the data doesn't care about narratives, right? Like, this somebody's last season, so you want to see them win a championship, or you like so and so and they haven't won, and you'd love to see them win the World Cup, things like that. Yeah, so let's talk about Ghana. So take a team like Ghana. Expert ranks them much higher than the model did, and that suggests analysts may be valuing things the model can't fully capture, or the model think the hype is too aggressive. And it's cool. It's cool to see that kind of interesting connection, right? Or correlation. So, and that's why the project ends with a hybrid approach, not just simulation, not just historical patterns, not just expert opinion, but all of them combined, right? And that can give us a full picture because soccer is chaotic, right? A pure data model misses misses like the context side, the story narratives. Um, but pure analyst opinion become emotional and narrative driven as well. So, all right, let's move on. All right, so let's do a conclusion here. Let's wrap this up. So obviously, all the models, the consensus, all has Spain, and that surprised me, right? To see that Spain came out on all three. After that, I was like, I'm gonna present this, and everybody's gonna think this is rigged. This guy's just a Spain fanboy, all this stuff. So I am not that. Like I said, I'm from the United States. I would love to see them win, but they're nowhere near on here, man. Maybe they go hot in the World Cup. But yeah, so it has Spain, okay? That doesn't mean they're guaranteed to win, obviously. They're just the strongest contender to win, okay? But yeah, one thing that surprised me during this project was how quickly the middle class of teams collapse, right? When you think about the World Cup, it feels like there are like 15 or 20 teams that could realistically win. And the data disagreed, right? Once the simulation stabilized, a very small group of elite teams started dominating every deep run, like Spain, France, England, right? Argentina. These few groups, okay? And it makes some sense. Over a single match, anybody can upset anybody, right? But surviving group stage, round of 32, round of 16, quarterfinals, semifinals, and that requires depth, right? And that's the difference between being dangerous and being championship caliber, right? Another thing that the models expose is how brutally hard it is to separate elite teams. Even the number one team only came out around 22% in the balanced simulations, which means the best team still loses most of the time, all right? Keep that in the back of your mind. And that's actually one of the coolest things about soccer is the sport has way more randomness than people realize. Low scoring, penalty shootouts, single elimination, momentum swings, right? One weird bounce can destroy 4 years of preparation. And one thing I found fascinating in the historical model is that historical champions are usually extremely balanced. Not necessarily the best offense or the best defense, but very balanced. Okay. And that's why part of why Spain kept surviving these models, the numbers weren't screaming most explosive team ever. The numbers were saying very few weaknesses, right? It's a very balanced team. And tournament soccer loves complete teams because eventually every weakness gets tested, okay? Another interesting thing is expert consensus was actually more conservative than the simulations in some areas. Analysts tend to trust historical powerhouses, which honestly makes sense because if Brazil underperforms once, people still emotionally trust Brazil, right? I mean, that's Brazil's like, yeah, everybody knows Brazil and has that trust about them. Yeah, so okay, so let's see what other notes did I have on here. Okay. And also an interesting observation too is that some massive football nations quietly underperformed in the models, not because they are bad, because their statistical profile wasn't separating from the pack, right? At the elite level, tiny differences matter. A slightly weaker defense, a lower goal differential, less consistent results against strong competition. Those little cracks start compounding over thousands and thousands of simulations. Okay. Yeah. So, but when you have all three of these pointing to something, you're filtering out the noise. It's the models and all this are saying Spain. So that is my fresh hot take from non-soccer guy making soccer prediction. I would go with Spain just based on all this modeling and things that I've done. Let me know what you think in the comments below. Is this align with what you think? Who do you have winning the World Cup? Let me know in the comments. I appreciate y'all. Enjoy watching the tournament and catch me for the next video. And bye.